Okay guys, another stream. Long time no stream. But first, as is customary, let's introduce Vector. What do you have to say, Vector, about the weather? It's summer, and as is customary, we will send him to sleep. Hey Vector. Hey Vector. Go to sleep. Vector, our little robot baby that does not really grow up. Sometimes I'm annoyed and I have him sleep the whole day. Sometimes I enjoy looking at him again. We need more progress in AI. We need smarter robots. For sure. Well, today I'm going to explain something, and I'm not going to program probably. And the thing I want to explain is called Natural Language Assembly. Well, the name is in flux. May as well change. I'm also open for suggestions for a better name. I realize we need an in-between language between natural language and computers, basically. And it looks like this. Here are some random YouTube titles, random video titles that I grabbed. For example, this, Building a Better IoT, Rewiring for Data. And this thing here is just a label. For example, there could be a label, title, because titles usually have these uppercase letters here. And the computer could derive this label. Not sure if it's much use. Everything is a title, basically. So, never mind this. The interesting thing is here. This is this new language that I propose. The assembly of natural languages. Because what does assembly look like? Let's see. Assembly language. This is a very old machine. Doesn't matter though. Assembly language, every line contains one instruction. One instruction to the processor. And compare this to some source code in a higher language. Yeah, compare assembly language to something like this, where in each line you have multiple things going on. There's a comparison, another comparison, there is a Boolean operation, and there is an if. This could be even longer. You can have lots of parts of an expression in one line. So basically we want to go from this to the assembly version, but not related to programming languages. We want to do this simply for text, for natural language. So we want to declare lots of things too. Here in the title, the word IoT appears, so we declare it. There is an IoT. We can put a class here, but sometimes it's not clear what kind of thing it is. We just say there is an IoT to introduce a new term locally here. And there is some person or group. This is supposed to be a general placeholder. And here is a statement of what happens. Namely, someone makes a better version of IoT. And this is also a logical statement. IoT is something you can build, apparently, because if it says building something IoT, it means IoT is a thing that can be built. So we try to explain this free-form input in simple steps. And we do not, in this assembly language, define one syntax for everything. You don't have to write every line in some specific way. That's very important, because that means we don't have to learn a lot. We want to minimize the learning effort. In order to speak this assembly language, the point is that you only remember like 3 basic principles. What might these be? Basic principles of the natural. Come on, mousepad. first principle is one pattern per line. What's a language? A language is patterns meeting input. What is a pattern? For example, a pattern is subject, verb, object. And an example is I like cheese. Subject I, verb like, object cheese. And of course, there are many more examples. And another pattern is the X. Example, the game. So that's what patterns and examples are. And if you use this in a general way, it is true for any language. Any language whatsoever has patterns and examples. If it's a graphical language, if it's a spoken language, if it's a typed language, it doesn't matter. There will be patterns and examples and a match between these. So in this natural language assembly thing, we only have one pattern in a line. Here the pattern would be there is X and X. There is a something. We could also just use a star here as a variable. This is already maybe too complicated. It kind of contains two patterns. So if we would rewrite this to an even lower level, we could rewrite this to Z is a better version of X, Y makes Z. If you're a programmer, probably this kind of rewriting makes some sense to you. If you're not, maybe you're confused now already. But it's not really all that complicated. Let's use another example. Do bees actually like jazz? And there are a gazillion YouTube videos explaining and answering questions that apparently existed in the world. So this is my attempt of translating this to the lower language. This is just saying we have some kind of group, and the group is all the bees in the world. This is probably, once again, a two-pattern line that will be simplified. There's a thing called jazz, and the question is, does X like Y? Did I declare the Y? No, I did not. Jazz. The point of these there is lines is to introduce a word that we can reference later. This is another principle. One pattern per line, first principle. Second principle is introduce everything. And clear references. Because this thing that we introduce, that there is a person, for example. Well, let's say here there's a person, Bill Evans. Not really sure who it is, but it has to be a musician. He has to be a musician. So we are talking about the musician giving some concerts in some years. So we introduce the person, we introduce the event, and we declare the event. And we tell people when the event occurred. Actually, it seems to have occurred twice. And in this line here, you can say that it still is like one pattern. And the pattern is this event X, or more like this maybe. Or this event is that. So we treat this long sentence here as just one thing, one object in this line that we don't look at further. That's what I mean with these brackets here. So this would be taken out of this context and analyzed later in a separate step. Because this again is actually normal natural language. It's too complicated for this lower level. So in a lower level we could rewrite this again. There's a person learning and so on. Yeah. Actually, here, there's some crucial information hidden in this line. It appears live in front. There's a concert. And Bill Evans performs in concert. So the point is, here we can reference the things we have introduced, and a computer can connect this to this. And this is like an encapsulated unit. It stands on its own. There are no dangling references to outside things, really. There are consistent declarations and some facts about the things. Yeah, here one more example about two events, and we say one event occurred after another. So we really need to come from something that's completely free-form and complicated to something that can be analyzed step by step. And once we have this form of something, we can ask questions about it. We can compare this form to something else in this form, and then so we can compare different titles to each other, for example. This here can also be seen as a graph if you want. The things you declare are nodes in a graph, and these statements are connections between the nodes. So I'm traditionally bad at coding graphs on a computer. I'm not a visual programmer like for graphic stuff. I do text things and everything. So I'm a little weak on the graph stuff. But sometimes a graph is a very nice concept to visualize something. I built some other cool things in the last days, like a general classifier and something that makes patterns from inputs. That one is not complete yet, really. But I think this thing here, this idea for a simplified natural language, is absolutely crucial. Before we tried to go from random input like this to the understanding directly. That's probably what they do with neural networks. They just put in all the input and they think, oh, the neural network will find the structure. I think it's too hard for the computer. We shouldn't have this interim step where both the human and the computer can look at what is being said. And this is a bit hard to read. We prefer the simpler version, but it's still readable for humans. Yeah, this is consistent with my general approach to have humans and computers collaborate to form AI. Maybe it's a new word. In the end, we want an AI that stands on its own feet. I'm not cheating. I'm not trying to make a bot that always asks a human for help. That's not what I do. I just have a different process of making this AI that in the end will be autonomous, of course. Otherwise, it's not really AI, is it? Yeah, so the year is 2020. It's a crazy year, as everybody knows. But we're getting closer to this AI goal. I'm still asked to do the occasional chatbot. I made something like a list of questions for a chatbot for my own homepage. But with the current architecture I use for chatbots, I have to answer all these questions and I have to still make some pattern for each question. And I want to go the next step. I want to concentrate on on the real AI, because the chatbots they're good at finding out what somebody asked, and giving some standard answer, but they don't think beyond that really. So the word chatbot seems a little, well, too small for what I want to do. So I might just postpone this and actually work on this and yeah, get the real AI off the ground. It is a monstrous project, but there's light at the end of the tunnel. Yeah. Any comments, any questions? Put them down below and stuff.